Okay, for people who are joining the live stream, this is a continuation of a discussion that we're having about microcontroller control from Wolfram Language. So let's see, remind me where we got to last time.
Last time we finished looking at a sample project documentation. But I think it will be good if we start with the microcontroller embed code ref page.
Okay.
Just go to the guide page on Xkernel and
on Xkernel, but wait a minute, is it in CVS?
No, it's a Git repo in the Packlet repository.
So
how am I going to?
This is what happened. Everything that's Packlet distributed, you can't edit, or you have to get set up with Stash.
Okay.
It's a different thing.
So we better get that set up for my machines. Can we?
I have no idea. I haven't got it set up for my, so I don't know.
Well, how do you do it?
We have looked at page. I've edited individual pages and then put it back there, but we don't have a
so I can't open the Okay, so we need to get that.
No. If you get the product, you can't get the sources right now.
Are you in Xkernel?
Yeah. Okay.
It's built in Xkernel.
Okay, so DocuTools isn't going to do me any good.
No. No, the Packlet framework is not, it's not really, it's developer only and nobody else type thing at this point.
Well, okay, so that's an issue. By the way, Roger, you have a lot of background wind type noise. Okay, all right. So we need a solution to this thing about the Packlet repository.
And yeah, I think that
How do I get to the relevant page here?
Search for it. MicrocontrollerKit.
Okay, so we went through some errors in the way this documentation was set up last time. Hopefully those will get fixed, right, Suba?
Yes, I'm in touch with Brady regarding that, and when Brian is back, we will finally get to that.
Okay, so Andrea is here as a project manager, right? So she can make sure that gets tracked down. And Andrea, can you please make sure that the other Roger figures out something about how I can edit Packlet documentation?
Sure.
Okay. Okay. Where are we starting now?
This must have come up before for you.
Actually, it hasn't specifically. Okay. So last time, we were talking about features of this design that didn't seem right.
Yeah, that's right.
Okay, so can you remind me what we concluded?
No, you wanted to look at, instead of having it as the second argument, microcontroller, instead of having it as 3 sub-arguments, whether to use an association, and we didn't resolve those things.
Okay. So which part here were we looking at?
Yeah. So where you have your mouse right now, that whole thing is the second argument. Yeah, that's the second argument.
So right. So this is the inputs.
Yes, and that's the outputs, and then additional options. The target name, list of inputs, list of outputs, and additional options. And that.
Okay. So in this case, the name. By the way, did I store any notes from last time?
I don't think so.
Okay. All right. So let's just bring up the example that you had previously.
So if you open another help viewer, you can have that happen parallel.
By the way, Andrea, could you also, the pink background here, could you please find out if that's a bug?
Yeah,
it looks like a bug, right?
It's a priority 1 bug, yes.
Okay, fine.
How do you know that, Suba?
because all the workflow is broken in the documentation. So I tracked it down, and it's just not this one. All the workflows complete in the entire build is broken.
Okay. So where are the examples? So these are the, okay, and we talked about the fact this has to be reformatted. By the way, are these pictures, why aren't they clickable? They should be clickable. Make sense?
Yes, that can, I have to talk to Brian again because this
Yeah, I understand.
Okay.
So I'm just saying they should be clickable. So let's make sure that happens. Okay. So how do I see this?
Yeah, so I sent you the notebook last time. So yeah.
Okay, so you need to send it to me again.
No, we are not. We don't want to do that.
I want to see it again, please.
No, because there's nothing different from the one I sent.
I know. I want to see it because it's a good example, so we can go through to look at it for the purposes of the design. Okay.
Just give me a minute.
And we spent some time on some device framework additions.
Which were what specifically? Do we have notes from the previous meeting?
I have like internal notes, and the relevant ones I passed on to Brady.
Okay, so what was the thing for the device framework?
The device submit, where we wanted to, because the other thing you said was very low level.
Mm-hmm. Okay, so can I see this example, please?
Yes.
Okay. So,
Yeah,
was this the same one we looked at last time?
Yeah. So this is not. Yeah, we want to go to the final one and look at how it's embedded.
Well, this is your inputs and outputs.
Mm-hmm. Yes.
And that's not how, for example, the way that GPIO works, right? It's different, if I'm not mistaken.
Yeah. In GPIO, it says 0 goes to serial.
Okay, fine. And why are we not doing that here?
Because that is setting, So because there it just does input and output, right?
Mm-hmm.
Yeah. That is like a very elementary thing. So a particular channel can be both input and output.
Okay, so but what we're saying here is the input channels, if I'm not mistaken, should be like an association that says, because you can't repeat the pins, right?
We can repeat the pins.
Really, what does it mean when there's an input pin, when there's two copies of input pin 1?
Yeah. So suppose it's an SPI input, right?
Mm-hmm.
So on the same pin, the input from different devices connected to the microcontroller will be coming on the same pin.
Okay.
So the way the microcontroller distinguishes which one it is by setting another pin low or high.
Okay. Now, have I been saving this someplace or not?
I did not see you saving anything last time.
Okay, I'm going to start saving this under ILD. I guess I'll save it under a microcontroller. Okay. So that's Andrea. That's for you. Okay. Okay. All right. So, then you also have these options here, right?
Yes. That is specific for each input and output channel.
Well, it's for each type of input and output channel. There are certain options, correct?
Yes.
So one question is kind of how to represent all of that stuff. I think that the way that we've typically done this in other places would be to say that the simplest form is this, but then there's a more decorated form that says something like type, serial, max value, whatever. This is the way it would work for an interpreter, for example. Am I making sense?
Yes.
Now, the way it would also work for an interpreter is you could say restricted. So, for example, we could say restricted integer, comma 10 would be a way of just saying, give me an integer less than 10. Right. So the typical case would be the name, and then let's say restricted integer 10. Am I making sense?
No, I'm not getting that restricted part. So why would?
Okay, so that's what we do in the case of interpreters, right? So an interpreter, we say as an error, if the so if I say interpreter, restricted.
Mhm. Okay.
Okay, if I say that, but if I say 11 here, it'll fail.
Yeah.
Okay, so that would be another metaphor for these kinds of things. If there's but I think this is the best thing to do, is to have something where you say one arrow serial, if that's the simplest case, or you say one arrow and then an association which gives all the properties of that pin. Am I making sense?
Yeah. Yeah. So let me explain some, because when we typically talk about channels, we're talking about multiple pins working together in tandem.
Okay.
Yeah. So we say that there is this pin, and I think what we could also do it like that. We could say that that is the slave select pin. The slave select pin would be a key. The slave select would be a key in that association you showed above.
Okay.
Yeah, that's
but I don't know what slave select does. I mean, so are you saying that there are multiple pins that should be together in this association, or what?
In that channel, that one goes to that association. So
is that a channel or a pin?
A channel is made up of one or more pins.
Okay, but is that one representing a pin?
Yes.
Okay, so how do we put multiple pins into a channel?
Some of them are like as those keys. And sometimes if I'm giving a differential input, like in ADC, sometimes there's a differential input. I'll give that first one as a pair, as both the pins.
Okay, so are you saying then that you would like something which says 1, 2 arrow,
yeah,
blah, blah,
that's
blah?
also a possibility, yes.
Okay, to represent a multi-pin combination.
Yeah.
Okay, seems reasonable to me. But now, when you refer to that in the microcontroller here, how are you referring to that input in the code for the microcontroller? How do you refer to that input?
Yeah. Okay. Yeah. Good. So go back to the ref page so I can explain.
Here.
Yeah. So right after that second table, you see. So when we say just the list of inputs and outputs, those where the position where they occur is mapped to the position of that sys. Is just mapped serially to the positions of the inputs and outputs of that first argument. But I also have a design which is a little below where your mouse is. The input goes to, yeah. So that way I can say the first input of sys goes to this channel, or the fifth input goes to that. I don't.
Okay, but when these are referenced in the code, what does it look like? In other words, if I'm making a state space model, the first element of the state space model, because the state space model is referring to different things by positionally, if I'm not mistaken, correct?
Yes. So in this case, the state space model has 2 inputs and 2 outputs. So
that's fine, but those are positional. That's the main point, right?
Yeah, they're positional. Yes.
Right. Okay. So we should explain. So here, okay. So what has to happen ultimately is that the input list and the output list. Okay. What do you mean? So a channel. Okay. So if I'm understanding correctly, the state space model has a list of channels as its inputs and outputs. Is that correct?
Yes.
Okay. So these are channel specifications. Okay. So that isn't. Okay. Input and output channel specifications. Okay.
Okay, let me backtrack. So the first argument is state space model with a list of inputs and outputs. The second argument is the microcontroller with its list of inputs and outputs. And how these two are mapped together is based on position. So the
Yeah, I
ordering,
get it. I get it. Okay, so the state space model has, just so I understand, okay, the state space model is basically, in a first approximation, some kind of generalized matrix. Is that true?
yes, yeah, is a
Okay, so if I take this state space model here,
mhm,
like say this one here, right?
yeah.
So now how do I feed it? Okay, so channel one, what do I do to actually do something with this?
Yeah, so it has, so this one has, because that you see that B, it has only one column, so it has one input.
Okay, so how do I give it an input and see what it does? Well,
So over here it's output response if you want to.
I'm sorry, what do you mean? How do I get?
No, if you want to simulate this with a particular input in Mathematica, to simulate it, we use output response.
Okay,
But
so
here,
there's a function output response. Is that
uh-huh,
right? Okay, so output response of that %36.
Well, you won't get anything. It's just purely symbolic.
it gets symbolic in this case.
It's a system of differential equations, Stephen.
Okay, fine. So let me take this case here. Right?
Okay, that's a little too simple, maybe, but
Well, okay, but I just want to know what do I feed in this input?
You give it an input 1, unit step T. Yeah,
Okay, that's different. So unit step of T, right?
Comma T.
Here.
Yeah.
Okay. So if I change that to, let's say I change that to 1/2 and this to 3 here, not knowing what any of these things actually mean. Okay, cool. Okay, right. So this is saying that state space model, when I feed it that input, unit step of T, it will generate this output.
Yes.
Right?
Yes.
Okay, terrific. Okay, so now the analog of that here is that I'm feeding the state space model. So instead of getting input, in this case, this is the output response from a simulation of this. But in a sense, I could equally well be getting input where this, instead of this being unit step of T, this is the voltage on, port on wire such and such. Is that right?
That unit step could be coming through that wire.
Yeah, okay, so fine. So let's understand how that works. So what you're saying is that this is the state space model as the first argument.
Yes.
And now what I want to do here is give it, this is hooking up. Well, so just if there was 2 inputs to this state space model, give me a version of the state space model that would require 2 inputs.
But what you're seeing, that PWM to speed has 2 inputs.
Well, I understand, but where is where is PWM to speed?
The one that you were just discussing. So you see that PWM to speed input.
Yeah, but what's encoder S? What does that mean?
Yeah, so encoder S, see that it's just it's just a scalar on top.
Okay, all right, fine. So
you can
sampling,
give whatever number, you can give encoder S to be that's 0.5. That's what it is.
okay.
And sampling
So
period
fine.
in this case is 1.
And sampling period is what?
1.
Okay. All right. So now I can say output response of that state space model. And again, what do I do? How many inputs do I give here? 2 inputs?
Yeah.
Okay. So I could say unit step of T and T, for example. Okay.
So and this one has 2 outputs, so it's going to give a list of 2.
Okay. Fine. So if I put in something there, okay, dandy. Okay, fine.
Yeah, and this one, it turns out, is just that it's just multiplying that matrix. It has no memory, so it's just that matrix times unit step.
Okay, can I give it some memory just so I see what's happening?
Yeah. So in the first argument, just give a random real of a 2x2 matrix. But you have to change everything.
No. For this, instead of that null list, what do I do? Instead of the null list, I do what?
You have to give a 2x2 matrix.
There. Okay.
Yeah. So everything should be a 2x2 matrix. The first, second, and third, all 3 of them.
Okay. So if I just say random real, let's say size, let's say going from -5 to 5. Let's see, I want a 2x2 by 3, correct? And now I want that. I'm going to do this in a very El Cheapo way. I just paste it in there, right?
Yes.
Okay, what happened there?
It's saying it's. Can you just copy paste just the state space model and evaluate it? Got dimensions. Nope. So
wait a minute, I got this wrong. This is transposed from what it should be. I should have said 3222. Much better. Sorry about that.
yeah, it's going to do symbolic simulation, which is going to take some time. So maybe.
Why is it doing symbolic simulation? Why can I?
Because yeah, oh, there's it.
Okay. So now if I were to like plot those as a function of t,
Yeah.
but there's nasty imaginary parts there.
No, it'll cancel out. It just.
Okay. So if I just say plot that, t goes from what? From what to what?
From 0 to 5 because it's a symbol.
Magnificent. Okay, so what is this doing? This is driving the thing with a unit step, and that's asking.
With unit step and t, the first input.
And a ramp. The t is a ramp here, Stephen.
Yeah, right, I get it. Okay, all right, okay, fine. Okay, I understand.
You know, but you don't need to get it symbolic. If you have t and some t min, t max, I think it uses numerical
Go
simulation.
from 0 to 5, then it's going to be a numeric simulation much faster.
Okay, so if I do the same thing again for the output response, and I say
t from 0 to 5. Yeah.
Okay, so that was because the sampling period was 1, but let's say I said the sampling period was 0.01.
Yeah,
then I'll get a whole bunch of things there. Why are those numbers so ridiculously huge?
Yeah, because it's probably unstable.
It's a ramp, and it might be unstable. You might have two things going on.
Still huge. How
that
come?
means it's unstable. It means that the dynamics, it's what you call chaos, or some people call chaos. It's sensitive to initial values.
And so that's just a feature of this particular choice of matrices and so on. Is that right?
Yes.
Okay. So why is it consistent to give functions in this case and to give lists of values in this case? Why is this not an interpolating function?
Yeah, so it's because this is a discrete time system, so it's sampling.
Okay, so if I got rid of the sampling period, it would give interpolating functions.
Yes, then it would be continuous time.
So that was, you know, when you use sample period, it's a difference equation, system of difference equations.
Right. It's kind of yucky that it gives such a different structure. But anyway, okay, fine. So that's beautiful. What that did there. I think it's yucky that it gives a different structure in the two cases. I mean, I think it should give something which is where somehow it's the values. But okay, let me not go chase that. Okay, so then I've got a state space model here, and the sampling period is the clock rate of the microcontroller. Is that right?
Yeah.
So there is a default sampling period. If I don't give the sampling period, when I embed code the thing, it will just go to the sampling frequency, to the clock frequency of the microcontroller. Yes.
No, it will not accept systems that are not discrete time. The first argument has to be a discrete time system.
Why?
Because that's the only thing that makes sense.
I don't understand. Why doesn't it discretize it by virtue of the fact that it is sampling it at a certain clock rate?
Yeah, but what discretization? What is the sampling period we should use?
Well, whatever is appropriate for that particular microcontroller.
No, that's ambiguous because that sampling period is like a design criteria. So if you use too high a sampling period, there are certain advantages. If there is too low, there and so on. So that's a trade-off that the designer.
Okay, but I don't understand. The state space model, we should be able to state the continuous time state space model. Then the question of what sampling period is given is a question for the actual deployment in a particular microcontroller, if I'm not mistaken.
No, it's like a trade-off. So if they use too high a sampling period, the system could be unstable. It won't sample fast enough. If I do it too fast.
I know, I understand, I got it. But the question of what the sampling period is determined. I can't have a sampling period that is faster than my microcontroller's clock speed, right?
No, yeah. It's going to
Okay.
be much slower than that because it also has to do some computations in the interim.
Fine, I understand. But what you set as a sampling period depends on what microcontroller you're using. If you're using a microcontroller that costs 1 cent and that only can run at a certain speed.
No, Stephen, you need to actually design, if you're going to discretize something, you need to see, are you going to be able, and you want to do that in Mathematica or Wolfram Language, you want to analyze it, see, can I in fact control it with this slow sample rate? And it
I
might
understand.
be slow. And there are other issues that happen that Suba was trying to explain when you sample too fast, which is that you can't run it on the
All right, but the point that I'm making is, I don't understand, is that something which should be part of the model, or is that something that's part of the embed code to specify the sampling period?
I think that it should be part of the model. I think it's a design choice.
Okay, fine. All right, fine.
Because they're too wild and too unpredictable if we just,
But there must be okay, so is it the case that most of these things have the possibility of going out of control? So
yes.
All right, fine. All right, so let's take a look now at this, okay? So this is saying I am going to compile that state space model for this microcontroller and stick it on this port.
Yes.
Right?
And that microcontroller is connected through that port. That's how I'm going to download it.
Yeah, I understand. So there's, as we talked about before, there's like boot, some kind of analog of the bootloader for the microcontroller. So that as soon as this has been done, the microcontroller will be ready to run, if I'm not mistaken, right?
Yes.
It will be ready to run, and we'll just run that state space model.
Yes.
So, but there's no way, we don't have to say clean out the microcontroller and repopulate it. It's just an overwrite type.
Yeah, it's an overwrite. It goes to flash memory. It's just overwritten. The new program gets.
Okay, and all microcontrollers work that way. They don't have like I can switch between 4 programs or something on a single microcontroller.
No, yeah.
Okay. So, all right. So what we talked about last time, as I recall, to me, the fact that it's just sitting in a list is kind of weird. I mean, it would make more sense to me if there was some kind of microcontroller head that could contain all that stuff.
Internally, I have it, but I didn't want to put another symbol. I have okay, not that. I have a symbol called microcontroller channel that holds that.
Well, what I'm suggesting is that this microcontroller thing would be a wrapper. So can you not ask questions about the microcontroller? So, for example, I might want to, if I had a symbolic microcontroller thing, right? I would have something. I mean, to me, I'm not wild about that list there. I mean, to me, I think it would be much better, and I think we talked about this last time, to say, type Arduino Uno, inputs, blah, 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 outputs, blah, blah, blah. Am I making sense?
Yeah. Or I would change that name type to target because that's what makes more sense.
Okay. Is it really a target? I mean, it's sitting right there.
It is a target.
Okay. All right. Okay. Okay.
There's a whole compilation that happens now for that target.
Yeah. Okay. Okay. So now if you did this, then you don't have then these options, the additional options for the microcontroller, which are things like what?
What you see from that, yeah, where and the one below above too. Yeah. All those.
Okay. So fine. So then this would say ADC arrow, blah, blah, blah. Is that correct?
Yes.
How do I know what the possible values of the ADC specifications are?
Yeah, so that's in the tutorial pages. And it's a
that's not really an adequate way to document. Okay, but that's not the right way for us to document this. So someplace, I mean, really probably what we should do is have pages for each of these things ultimately. Okay, so what is the programming mechanism?
Yeah, so that's now the third argument. So yeah, the third argument to embed microcontroller code, P. So first I explain sys, then we explain microcontroller, and then we are getting to P. So now when you go to P, you're going to the next argument. So I think.
By the way, we don't say association as a link there. We just say as an association, just like you would say as a list. Okay.
Okay.
Okay. So now. Okay. So these are not attributes of the microcontroller. These are attributes of this particular programming of the microcontroller. Like the baud rate is the speed at which the program will be sent to the microcontroller.
Exactly. Yeah. Yeah, and so that's why we have it there. So it would distinguish. So when the microcontroller is operating, suppose it has a serial port, and that time it has to have a baud rate that is given in the serial channel, and that's distinct from this baud rate.
Okay, so then that third argument. So you're saying. So ultimately, we might have a thing that says microcontroller embed code, microcontroller, blah, blah, blah. No, that's not part of that. That's part of the microcontroller.
The first argument would be a system.
Oh, yeah. Right. So it's a state space model. Is that right? Typically. Is there
or transfer function model.
Okay, all right, fine. So then there's microcontroller. Yeah, okay. So then there's the microcontroller. And then there's a list, there's a further association, which could also be a list of things that say things like the baud rate. Mm-hmm. Now, where are these options going? Clean intermediate.
These options are options to the function itself. Yeah. So after explaining P, those are options to embed.
Okay, but we can't have string options. So why are those not connected here? Why are those not here?
No, because these things. So these, the last table that you see, yeah, those option names come from other places in the system, like create executable and so on. Working directory. There's already the symbols like working directory and so on.
But that's not a symbol; it's a string.
Yeah, the string. Yeah, the string version of.
Okay, so what you're saying is this is now the list of programmer stuff. So that programmer in this sense, like baud rate, arrow, whatever, right? Yeah. And then there's a final argument.
No, not final, just a list of options.
But that's not going to work because options are not string named things. Do you understand what I'm saying? Function options aren't string named things. Okay, it's not how we set it up.
Okay, so a couple of things. So if we do that, then we are breaking precedence with embed code.
How does embed code work?
Embed code only has 3 arguments, and all the rest after that is.
So you're telling me I'm being inconsistent here.
If you add one more argument.
No. Look, options for embed code are symbols. Do you understand?
Mm-hmm, yeah.
Okay, these are not symbols. We don't use strings as options because we can't document that. Do you understand what I'm saying?
Okay, so let me bring up the second point. So that string working directory. It's already used by create executable. It's already used in our.
No. So that's fine. It should be then a symbol here. But then there are problems with all the other stuff here, because you probably used them in a different setting or meaning. You know.
What are you talking about? I mean, I don't understand. These are not. Are you saying that there are other functions that use the same names?
Yes.
Which other functions are they?
Say for create executable, can you look at create executable?
I hope that's not your function.
Nope. Yeah, and
okay, but that's part of some other. That's part of some package for C compilers.
And this will also be a package for microcontrollers.
I understand, but that's not. This isn't. Why was that? By the way, and Andrea, could you please report the fact that that doesn't have a thumbnail image?
And I noticed that all these packages don't have thumbnail images.
Okay, Andrea, are you?
Yes, I'm here.
But please make sure that you communicate that to Brian, that he gets that fixed.
Okay.
Did you understand what we were talking about?
The thumbnails.
Yeah, underneath details, right?
Yes.
Okay. All right, so this is breaking our usual conventions. And it's not really a great idea. Yeah, this is not really the right thing to do. You know, in modern times, these should be in an association.
I would say completely yes for system functions, and we can do it for a package too.
Yeah, I know. This is sloppy, and it shouldn't be this way. But you know, I guess you can start out this way. I mean, you can continue supporting it later, but I think it should be in an association. Am I making sense? Suba, you understand what I'm saying?
Yeah, I understand what you're saying. Yeah.
Is there a problem?
Yeah, I can change that to an association now. It's
Fine.
just that because it breaks precedence with create executable. That's
I don't care. Right? Create executable is wrong and should be fixed. But create executable is surely going to be built, you know, changed when the compiler comes in, right?
okay.
Am I making sense?
Yes, and yeah, and there are other places too. Like I think even Ian's Arduino. Like,
Well, then it's probably wrong. Okay.
it's other places too. It's just not my.
Okay, fine. I understand. So it's not your mistake. Somebody else started making that mistake, but let's not propagate the mistake. Okay. I mean, you can go ahead if you want to and treat these as options for right now. I don't like it, but we better to put them in an association. But then, Andrea, we're going to need to go through and clean up all the rest of these. Making sense?
Yes.
And that, I mean, that's a different project, and we don't need to solve that right now. Okay.
So I'll be safe if I just switch that to an association.
Yes, that's fine. I mean, you can support having it in raw options as well, just for fun. Okay. Am I making sense?
Yes.
Okay. All right. So now, with respect to this, the question is, do we want to put this in an association? I think we do. I do not think we want that naked list there. I think as a courtesy, we could allow a list, but it should turn itself into, I mean, I think this is a better thing to have, especially since then you can ask for properties of the microcontroller object. Am I making sense?
Yeah. No. Yeah.
Is there a problem with this?
What is microcontroller going to do?
Nothing. It's going to sit there. It's a symbolic representation of a microcontroller. It does nothing.
But it's more than a microcontroller. It's the mapping from your input. It's specific to that state space model that you gave. The mapping.
I see.
Yeah, I think without the microcontroller, just having the association is.
All right, fine. Okay, fine. Okay, let's talk about these inputs here. Okay. So again, what I think we should do is something like this. Am I making sense? So that input there, so it's going to basically say inputs, arrow, and then it's going to be a list of those inputs. And in the case where, for example, 2 is a pure, I don't know what it says, you know, analog. I don't know if that's a possibility.
Yes.
Then we can do that. But in the case where you want to be more specific and you want to give options, you turn it into an association. Does that make sense?
Yes, it does. Okay, so my question, so doesn't this make the code more verbose?
Yes, it does. It also makes it more consistent and more readable.
Okay.
Okay, so let's see, what else do we have to figure out here? So this then returns microcontroller code data. So this has sent it as a side effect to that port. Is that correct?
Yes.
What happens if I don't want it sent to the port? If I just want to generate the code but do not want it sent to a port?
Yeah, so we can, there's this option, create binary goes to false.
Oh, for God's sake. And then, but then what happens to the third argument? Is it ignored?
Yeah, it's ignored.
That's a really cruddy design.
Well, we weren't targeting that case.
Okay, so that case is that case not of interest?
Yeah, yeah.
Well, then we should have another function because it's not embedding.
Is it of interest or is it not of interest? The case where we just generate the code, but
it could be of some interest. Okay, the C code, but not the next level down, because then you can then edit that code. You can inject other things.
I see. Okay.
You know, but it's not a main. You know, it's.
All right. Okay. So fine. So what that would be is something like I mean, embed code normally as a mechanism for returning. Well, normally embed code returns a string. It does not have a side effect and send it anywhere.
Well, this one actually embeds it.
And then we can ask a property at the source code, and it will give back the source code that was.
Okay, I think this name is wrong then. Okay, this isn't embed code gives you the embed code. This is actually.
These are embedded code. This is what embedded code is.
No, I understand. I understand. But the function embed code gives you the embed code, if you understand what I'm saying. In other words, it gives you the code which for embedding. What this is doing, it is actually embedding the code.
Yeah, exactly.
Right? I know. But so the meaning of embed code is different in these two cases. In the other case, embed is an adjective, right? Meaning code which can be embedded.
Yeah.
In this case, it means actually send it to the microcontroller.
Yes.
Right? Okay, so I think the name here is wrong.
Okay, so because originally we had the name embed microcontroller code.
Well, I think that's wrong too, because I think, look, okay, hold on. What is the action of sending code to a microcontroller called?
Embedding code.
It is?
Yes. It's embedding the code or uploading the code to the microcontroller.
Okay, well, I think that would make, but this function, okay, so we've got two operations that are going on here. We've got generating the embed code, right?
Yes.
This is for which we would return we would return this thing here, correct?
Yeah.
Okay, so we've got this. There's no baud rate stuff or anything like that there, right?
No.
In fact, the last arguments, is it correct that the last two arguments are irrelevant?
Yeah.
Or is it not correct? Or is this argument here is irrelevant if we're not actually sending it to a microcontroller, correct?
Yeah, but in that one is not relevant if you don't have.
But this argument is relevant.
Some of it, like I squared C, SPI, and so on.
Okay, so that's a bit of a mess. Okay, because we've got a situation where this one here.
We still want the complete thing, the one-liner thing.
Of course we do.
If you want to build two separate functions.
Of course we do. Of course we do. But I'm trying to understand, this thing here is optional and depends on the fact that it is being sent specifically to the microcontroller, right? Whereas this here affects what code is built for the microcontroller. Am I making sense? Is that correct?
Yes. Yeah. What is the compiler that's being used? What are
yeah, right. But that's determining what this return value will have in it, correct?
Yes.
Okay. Whereas these options here do not affect what is in that return value. Is that correct?
I don't know whether I put it, but we could say from which compiler we used and so on. We could add it there. Because that.
No, wait a second. This is to do with communication to the microcontroller.
Yeah, you're right. Yeah.
Right? Okay, so that is communication, and you should say, rather than calling it P, why don't you call this communication or something, or COM, C-O-M-M, or something like that?
Okay.
And using P, communicating with the microcontroller using this thing, right?
Yeah, P for port, that's why.
But it's not a port.
The serial port, for example.
But it's not, there, I see. So that says connection port.
Yeah.
Okay, well, okay, fine. But that's, okay, so the thing we have to do, so I mean, one thing that we have might be called generate microcontroller code. And that would then produce this microcontroller code data. That makes sense?
Okay, possible, okay.
Okay. And the other one could be something like upload microcontroller code. Okay. And then what could happen is upload microcontroller code. If you give it, instead of a state space model there, well, actually, it's the first two arguments that are being replaced by the microcontroller code data. Is that correct?
Yes. Yeah.
Okay, so that's a little bit of a mess again, right? Because what we're saying then is that in upload, Sandra, our live stream, is pointing out that it's often called programming the microcontroller, which is obviously true. But although programming doesn't really actually say whether you're doing the embedding or not.
Yeah, it does. So the programming is the file that loads it up on the flash and manages that whole process.
Because there's
a weird name. It's a totally weird name, but you get used to it after a while.
Right. Okay. Okay. So let's look here. So then, upload microcontroller code would either take directly to the state space model, or it could take microcontroller code data which had already been produced.
Upload.
Do you understand what I'm saying?
Oh, you're trying to have a save one function? Well, why don't we add a third function that does the whole thing?
I'm not saving one function. I'm saying, look, this function here. Okay,
I understand where you're going, but why don't we just have a third function that does the whole thing, and that's the short one. You know, we can have these separate functions if you want. That you take it apart now, but I think we should have one that has.
All right. Okay. If you really want to do that, it seems silly to me. I mean, okay. Upload. Okay. So this upload would then take the MCD, the microcontroller code data, together with the
programmer.
No, together with this, together with the dev tty whatever, right? Together with whatever the specification is, this specification here about baud rates and so on. Am I making sense? Like we'll take as an example here baud rate.
Yeah, but why did you split that two? Because the baud rate and the connection port are all together. The dev tty, the baud rate.
Oh, I see. So then the documentation was okay. Okay, so what you're saying is there's a default baud rate. Is that correct?
Yeah. So this is what. So if you just give dev tty, it takes that to be connection port goes to dev tty. That's just syntactic sugar.
Okay, but so you're telling me there's a default baud rate, right? Because you're not specifying the baud rate then. Am I making sense?
Yeah, there is a yeah. So when we say Arduino Uno, we know what baud rate we should send. Yeah. So there's a.
Oh, you do.
Yeah.
So this baud rate here is overriding that baud rate. Is that correct?
If people want to override it, exactly.
Okay. All right. Okay. Fine. So there is a default baud rate, as I was saying.
Yes.
But the default baud rate is actually automatic, because it depends on the microcontroller that you referred to, right?
Yes.
Okay. Okay. So upload wouldn't return microcontroller code data. It would return success. Am I making sense?
Okay, yeah.
Do you understand? I mean, because it's doing an upload. It's doing something with a side effect.
Yeah.
Right?
It could. Failure or success.
So it's a little weird, right? That this thing here, the combined one, is returning this microcontroller code data, even though it had a side effect.
I don't think you'll use these separate functions unless you run into trouble.
No, I understand. That's why I was trying to make something. Okay, look, having something where the way you get out the string is by setting some weird option, and then it produces a completely different structure of result isn't.
I agree. So we have just defined two new functions.
Right, but then you're telling me that nobody's ever going to use them.
Well, I'm not saying that, but I don't think it's a mainline use case.
Okay, but so let's figure out what the mainline use case is that doesn't have some wacky thing. Okay, so this mainline use case is using as its success indicator returning this microcontroller code data object. Is that right?
Yeah, those colors there are indicators. They might be red, and then one of the stages failed.
Those two LEDs you see?
Yes, I understand. I got it. I understand. Okay, fine. So that is the alternative. So are you suggesting that this upload function returns one of these things instead of success or failure?
No, that one can very well return success or failure. If we design them, but I don't think that the complete one you should still have. You shouldn't be forced to use these other functions that you design.
I understand that. I got it. I actually don't think that one needs. I think this function could do the whole thing. In other words, what I'm proposing is that you have two possibilities for what this has as its first argument. One possibility is you give it a state space model and this target information. Am I making sense?
Yeah.
The other possibility is you give it a pre-baked microcontroller code data object.
Yeah, that's a possibility too. So I didn't implement it, but I thought, yeah, I can give that as the first argument, give the second argument as automatic and port and.
No, you're not understanding the point. Okay, what I'm telling you is this. Look, this function, right? Yeah. No, let's do it more carefully, right? It's not a good idea to just say automatic for the second argument, right?
It's automatic because.
I know, because you know it, because it's in the microcontroller code data, right?
Yes.
Okay. So, all right, now we were also talking, okay, so this huge mess here, right? We were talking about how to avoid that huge mess.
Mm-hmm.
What was the answer to that?
We didn't reach any conclusion. So that involves also discussion with the device framework folk. But
okay, well, so just so I understand, this is the non-autonomous mode of using the microcontroller, right? Because this produces an autonomous microcontroller that you can just deploy on the moon and it'll keep doing what it's doing, right?
Correct.
Okay, whereas this is pinging the microcontroller and trying to get it to do something, right?
Yes.
Okay. So just so I understand, okay, so we still need to clean this design here, but let me just go back to the guide page. Okay, what's microcontroller targets?
So those lists all the ones we support.
Is that really the right place to put it in? Is that really the right? Why isn't that dollar microcontroller targets? Because you can give it that name there?
Yes.
That's not usually the way we would do something like this.
I think
well,
that's in a precedent somewhere. Okay.
Devices is a precedent. If I say devices, I think.
That's if you connect something.
Don't tell them this will hang. Oh, there we go. Okay, so those are device objects on my machine. That's trying to scan my machine for devices. What is the difference between devices and find devices? I don't believe this is the correct form here. This would mean what microcontrollers are connected to my machine, not what microcontrollers are supported by the system. I mean, the more common would be something like dollar import formats, right? That would be the more common way to do this. Am I making sense?
Yeah, but if you want to enumerate everything like this, it's going to get out of hand.
So what's your point? Your point is you want to enumerate them, selecting the ones that start with the word Arduino?
Yeah, so if you just give an empty argument, it will return what options we can give. Then we can give the list of vendors. If you just open scope, you can see some other possibilities.
Okay, I think this is a hacky function.
See, these are the families. Then you can ask.
Yeah, okay, so this is a completely hacky function. I mean, okay, so where is this data coming from? This is built-in stuff in the system that's defining what possible targets there are. Is that right?
Yeah, because once we start supporting something, we add it to this list.
I understand. Where else have we had a situation like this? We have a situation like this in system information to some extent. Roger, where else do we have something like this? This is
This is going to be potentially very large, so I'm not sure. Yeah, system information is it's.
See, I mean, like, for example, okay, so what we would normally do is some kind of entities thing. So for instance, if I say entity list, of quotes elements, for example. I'll get a list of hopefully chemical elements, right? So another natural way to do this would be using the elements, the entity system. Am I making sense?
No.
What, you don't understand?
I understand, but how, isn't that overkill?
No, not really, because that way, if we use the entity system, okay, then, for example, we can go and get this AT mega blah, 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 treat it as an entity, have properties of it, so you can ask things about that microcontroller.
Yeah, we want to, yeah, we put, yeah, that's a possibility. We wanted to go down that road, but we decided for the first cut, we won't have time.
Okay, well, so the good news is that it's super easy to make this work. Okay, all we do is we make use entity store. Okay, you literally just put these lists into entity store and you'll make this work. Do you get what I'm saying?
Okay.
And that way, also for this, so any one of these things, then that you've already got the information you need. Okay, if you want to understand how entity store works, you could ask like Tony Schindler, or you could ask anybody in the Wolfram Alpha group.
Okay.
This is the right solution, and this will be quite nice actually. So, and then as a courtesy, what you can do in the microcontroller functions is you can take a string. The string will be the canonical name for the entity. The entity would be something that says, you know, entity microcontroller type, probably microcontroller or microcontroller type, and then one of these things, right? Adafruit Mentor, let's say. Does that make sense?
Okay.
And I mean, look, I can show you how to do this. It's really, 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 really easy. I mean, you basically just give a list of entities. There's the list of entities. Then you give properties of each entity. Okay. Now these things here become entity classes. Again, you can ask any of the people who works on Entity Store how to do this. It's like super straightforward.
Okay.
Make sense?
Yeah. So, well, does what you're discussing tie into resource object?
No, has nothing to do with resource object.
Okay, because we're also thinking that we wanted to actually create like web pages for each and populate them.
Great, you can do that. So there is a okay. What we've done with that's a different approach, right? Okay, let's talk about this. Okay, is there code associated with each of these microcontrollers? What do you have to store associated with each microcontroller?
Right now we only, yeah. So right now over here, microcontroller targets only stores these names, but with each microcontroller internally, we store the default operating voltage, clock frequency, the pin maps, and so on.
Okay, so
there's a whole bunch of things that, yeah.
Okay, so those would fit naturally into the entity system. Okay. The alternative is to say that each microcontroller is its own island. Okay, let's talk about the two cases. The resource system is intended for something where there is a like, for example, net models. Okay, I mean, I do think that this might fit into the resource system in some way, because let's see. I mean, so here, for example, right, you could imagine that each microcontroller appears on this page.
Mm-hmm. Yeah.
Right? And it is not natural. Yeah, I mean, here, it's not really an entity property story. It's a story of there's one big blob of stuff that is coming out of, that is being stored in the repository. So, for example, if you had the drivers for a microcontroller, the repository might make more sense. Am I making sense? Yes?
Yeah. So, yes.
Okay. With entities, the way that we're doing documentation for those is right now, we'll have a page for an entity type, which will list sample entities. Like, for example, for cities, we don't list every city and have a page for every city. Instead, we have a page for the entity type city on which we list sample, 200 sample cities or something. Am I making sense?
Okay. Yeah. Okay.
Because there's very much uniformity in the way that those things are treated, right?
Okay.
Whereas here, for the neural net repository, every neural net is its own completely separate story. So if these microcontrollers are pretty much, you need to know the operating voltage, the frequency, whatever else, there's like a few attributes you need to know about it, then it will naturally fit in an entity store. If, on the other hand, each microcontroller sort of sings and dances in a completely different way, and if they're not sort of compatible, okay, so the neural nets, you see this is, some random neural net that looks at visual images, right? I could look back here and I could find some other neural net that is about speech recognition, right? So the operation of those neural nets is utterly different in those two cases. Am I making sense?
Yeah, yeah.
Okay, so on the other hand, in the case of cities, every city has the same basic properties. Am I making sense?
Yeah.
So which is the right model for microcontrollers?
I think probably entity, because for each microcontroller we'll have a set, we'll have also a table which describes what are the input and output pins available and how they can be configured.
Okay, fine. So it's really tabular data. It's not something where so for example, if you make documentation pages for these things, is it the case that the Arduino LilyPad simple or the Arduino LilyPad, what would be different between the Arduino LilyPad page and the Spark Fun Red Stick page?
Yeah, so probably the number of pins, possibly the operating voltage, the clock frequency.
Okay, fine, but it's very structured data. It's not the case that one of them you say, this one, you don't, because for the neural nets, right? Every neural net has a completely different piece of documentation. Get what I'm saying?
Yeah.
Because this is doing, it's got an audio capture and this and that and the other. Whereas if you were doing that for your microcontrollers, these separate documentation pages will be incredibly monotonous, if I'm understanding correctly.
Yeah, they would have a common template and the information in that will change.
No, I understand, but it's just tabular information, like the population of a city and things. It's not, it's not saying this is a network that does speech and needs to be programmed this way versus this is a network that does something else, right?
Yes, yeah. Here there are not those distinctions.
Okay, fine. Then I think the right thing is an entity store. Okay, go find out how to make entity stores. And as I said, just so we're not confused, what am I saying? In your actual code, you can use a string instead of the actual entity as a kind of courtesy. Am I making sense? And it will just convert it into the entity.
I see. Okay.
Do you understand?
Yeah, I think I do. Yeah.
Okay, so let me show you an example so you make sure you understand. Okay. So I think we have a thing called country data, although it's almost. So I could go ahead and I could say country data of France, population, if I wanted to. Okay. Right. So that will give a result. But now I can also get the entity France, right? And then I could just say this if I want to, and hopefully it'll give the same result. Interesting, they're slightly different because this is older. But I can also take this, okay, and do that. Okay, get what I'm saying?
Okay.
But so this is a courtesy usage, but the real usage is to have an entity there.
Okay.
Right. So that's what I'm saying you should do in the case of these functions of yours. Make sense?
Yeah. So what will this be called? What is that?
Probably the entity type will be microcontroller, I would think. You might need a separate one. You might need microcontroller and microcontroller vendor, possibly. I don't know.
Okay, we have microcontroller families and vendor. Those are the two main.
Okay, fine. Well, then you might need a thing called microcontroller family. You might need another entity type called microcontroller family.
I'm going to have to leave, fortunately. We're over time, but
I also am 15 minutes late to something. Why don't you? I mean, we're very close to finishing here. I would prefer not to have to schedule yet another meeting for this. Okay, so you're going to turn this into an entity store. Go find out how to do that. You're going to need 3 entity types, probably, based on what you told me. Make sense?
Yeah. Okay.
Okay. With respect to this, the only thing that I think is left hanging here is the way that these 2 functions work, right?
Yes.
And okay, so here, this microcontroller code data is something that you can then query, right?
Mm-hmm.
But those things that you're querying are different things than the things that went in to the generate microcontroller code, correct?
They can be like the default values that were used, and so on. So if the user, for example, didn't specify that operating voltage, it used
No,
something.
I understand. But the things that you can ask for here are all the things that you can ask for here, like standard error. I don't think that's something that comes from the actual microcontroller type, not from something that you fed in the microcontroller in the generate microcontroller code function. Is that correct?
Yeah, the standard error comes from actually invoking the compiler and saying if there was some error in compiling the code and so on. That information is coming back to the standard error.
But that's a bad name for this. That's the output on standard error, right?
Yeah.
It will be standard error log or something will be the right name for that. Standard error itself means something different, right? Exit code means what it means, right?
Yeah, so it's the same thing as it's used else. So with exit code, you also get standard error, standard output, and so on. That's the same symbols that are the same strings that are used here.
No, I don't understand. The strings are those strings coming from what is it called? Run process,
start process, and so on.
Okay, fair enough. Okay, all right. So the one remaining thing is what to name this thing here and how to deal with the fact that you're giving two arguments here, because you're giving both the model and the way that model is mapped to the microcontroller, correct?
Yeah.
So it's the model and the mapping.
Yeah. First is yeah.
Right? So it's model and mapping. And the alternative is that microcontroller code data contains both the model and the mapping, right?
Yeah.
Right. So just to understand the argument sequence here, we've got, I mean, if we were going to say, we'd say microcontroller, I can't spell that word. Okay, so if I say upload microcontroller code, there will be the model, the mapping, then the next argument is the communication info, and the final argument is what?
What do we? Yeah, that's
the final argument is what? It's the options that you're giving for what? Do you understand what I'm asking?
It's the options about what are the external devices. It's a mixed bag. What's the external devices connected? What are the compilation options and so on?
Okay, so why is that not part of the communication info?
Because what is connected is, for example, any device that is connected to the microcontroller is distinct from how the code itself is uploaded to the microcontroller.
Okay, so this is uploading method, basically. That argument is uploading method. Is that right?
Yes.
Okay, and the final argument is what?
It's just the disjointed collection of options. It does how to options for compiling the code.
Yeah, but there are options that relate.
I'm meeting the city chairman. I gotta go. Okay.
It's options for how to it's options about how to compile the code. It's options about what are some of the devices connected to the microcontroller and so on.
Okay. Does it relate? Is it factored from that option there? Or is there what is the difference between things that go in this option versus things that go in the general options?
So in the third one, the uploading method is only what is being uploaded.
No, it's not what's being uploaded. It has nothing to do with what's being uploaded. It has to do with things like baud rates, right?
That's the speed at which it's being uploaded.
I'm well aware, right? But and this has to do with on the microcontroller. No, the programmer name comes from where?
Yeah. So the programmer is a software in the tool chain.
I know that.
Yeah.
I know that. Why is that different from the compiler name? Why is it a different kind of thing from the compiler name?
Because they're two different. things.
No. I understand that they're different. I want to know what is the difference between this block of options and this block of options.
Okay. So those block of options, the uploading mechanism, those things are completely just for uploading, whether it's uploaded through that connection port or that baud rate or the programmer and so on. That compiler stage happens before the uploading.
Okay, fine. So all of this is happening before the uploading.
Yes.
Okay. So really these options are, but those options, are they relevant to generating microcontroller code without uploading? They are, aren't they?
They are, yeah.
Okay. So would it make sense to add those options in here where you've got what we're calling mapping right now?
No, there are two distinct things. Because see, for example, look at that I squared C. So I squared C, there can be properties of the I squared C that are for the microcontroller that come in the second argument. That I squared C, which is now the option or the fourth argument, refers to I squared C devices that are connected to the microcontroller. They're two different things.
I'm sorry. So the I squared C here globally affects.
They are external I squared C devices. They're not the microcontroller's I squared C. And
what do you mean by external ones?
Because there can be I squared C devices connected to the microcontroller.
As opposed to the ones that are used for uploading to the microcontroller.
No. Okay. So the microcontroller itself has an I squared C bus, and it's communicating to various external I squared C devices. So any I squared C properties that are for the external devices, we specify using what is highlighted. But I squared C properties that are inherent, that are part of the microcontroller itself, go in the second argument.
Okay. Didn't not quite understand that, but
because I squared C, so the microcontroller itself is an I squared C device. It has, say, an I squared C feature that is talking to another I squared C external device external to it. So we have to configure now both these devices, both the microcontroller and also the other I squared C device connected to the microcontroller. So whatever specification we need for the microcontroller goes in the second argument, and that option, what I have now, I squared C, is specifying things for the things external to the microcontroller.
All right. Okay. Look, the only real issue we have here is that we've got two arguments in one of these functions and one argument in the other function. Two arguments, and we've also got this ordering that doesn't make any sense because the uploading method doesn't make any sense for generate microcontroller code.
Yeah.
Right? Yeah. So let's walk through what we do have. So, and these arguments here, they do make sense for generate microcontroller code, yes or no?
Yes, they do. Yeah, some of them do, some of them don't. Yeah.
Humph. Okay.
Yeah.
So in general, then, so this would be model, mapping, and then random options, basically, is what you're telling me.
Yes.
Okay. Humph, how to do this? You see the problem, right? That here, you get the problem, right?
Yeah, I get it. Maybe the more fundamental issue is actually renaming that function to something else, microcontroller embed code.
Well, I know we want to do that. We need to rename it. Okay, so look, this is a way that would solve that problem, although I'm not sure it's the best, I'm not sure it's beautiful, is to put those in a list. Okay?
Yeah. That's possible, yes.
Then we would have something. So then here, we would always be able to say, upload microcontroller code. Then this would work. I mean, okay, so the two cases are, so that has your random options. Then this function, it compulsorily has this thing, because otherwise it doesn't know what to do, right?
Yeah.
Is that correct?
Yes, we have to give it yes.
Okay. And then the third argument becomes the options.
Yeah.
I think this is a reasonable solution. Okay? Okay, you get it?
Yes, so we'll have two functions, generate
Two functions. Generate microcontroller code, which does that. This one, if it really goes splat, I guess it could return a failure object. I don't know whether this should return. I mean, if you think it's convenient to return the microcontroller code data from upload microcontroller code, I guess we can do that. It's a little bit of a hack. It's a little bit hacky.
I think it should, because I'm not quite sure whether that microcontroller code data also contains information about uploading code. It's possible there are one or two. I have to double check. It's possible.
Okay, well, fine. I mean, then, okay. If
we
go ahead.
split it now into two functions, right? So all these examples that we just had at one line are now going to be two functions.
No, they're not. No, they're not. No, listen to what I said. Right? The whole point of making that able to be one argument there is that you can also do this. Do you understand?
Oh, I see. Okay, got it. Okay.
Right? It's just one function in that case.
Okay. So we'll have upload microcontroller code, and then I also create another utility, generate microcontroller code.
That's correct. And the way that we deal with that, because this can generate a microcontroller code data. So in the case where you got a microcontroller code data out from upload microcontroller code, then what you could do is take that and say upload microcontroller code again. For example, let's say you want to program 10 Arduinos to do the same thing. Am I making sense?
Yes, yeah.
Then I assume that what you could do is use upload microcontroller. I mean, the best way to do that would be to say generate microcontroller code, get the microcontroller code data, then run this 10 times with different devices, right?
Yeah.
But the other way to do it, this sort of weirdo way to do it, is to do an upload microcontroller code once, get the microcontroller code data, then take that microcontroller code data and rerun upload microcontroller code with the different devices. Make sense?
Yeah. So yeah. So now I get it. Yeah. So if you put those two in the first argument, and yeah, now yeah.
I think it's a decent. I think it's an improvement. Okay. All right. I think we are done here.
Okay. So is where do you store this notebook?
I'll send it to you, or Andrea can send it to you. She knows where it is. I'll send it to you.
Do you all of you have access to Dropbox?
Suba probably does not.
Okay. Anyways, I can attach it in.
I'll send this to him.
Okay. Thanks.
And I'm copying you. Somebody from our live stream before we hang up makes a very sensible point. Why not have a connection object that describes the host port and connection parameters, making it independent of the code being uploaded? Yes, that is what we are doing. That's we could have an actual connection object, but we just have an association right now that represents that. And yes, it is independent of the code being uploaded. That was, in fact, the point of my whole big fuss here. Okay, so the remaining thing that has not been addressed is improving the device framework to be able to deal with making this much simpler.
Yes. Yeah.
And you believe that device submit is basically the way to do that?
Yeah, I think so. Yeah.
But device submit is the analog of device execute, but for asynchronous operations. Is that correct?
So yeah. So device execute. Let me see.
No, device execute is what will send. I mean, this is unbelievably grotesque. This whole thing here. I mean, what device submit would do is it could define certain events. But I don't even know what those events are because you've got all kinds of weird stuff with terminator bytes, you know, start bytes and end bytes and so on.
Yeah, so the entire design would involve these bytes actually being part of the device object itself to begin with. and then so it automatically knows these things. So
what the start byte and the end byte is, but how? Okay. So you do a device submit. I mean, the way submit stuff works, if you look at URL submit, for example, right? You know how these things work, yes?
Yeah, we look, yeah, session submit URL.
No, but session submit is a little different from, well, I guess it's the point about URL submit is it has particular, the following events can be generated, body received, blah, 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 right? So those are the things that you respond to, okay? So the point here is that what you're presumably doing is you're responding to certain events that certain bytes were received, if I'm not mistaken. And so, for example, what you can respond to then is, I don't know whether this is start byte, end byte, so that's a serial packet or something was received. Is that correct?
Yeah, what you're seeing there is we are writing, so it's just you're writing that out.
Okay, fine. But then okay, so why isn't device write the right way to do that? Why does it have to be asynchronous with submit?
Yeah, because we are both reading and writing. So we first read and then we write.
Okay, but isn't that a synchronous command, a synchronous operation to read?
Yeah. So okay. So ask that question again.
Okay. Why do you think that this should be asynchronous? Why is there this whole operation? You want the whole operation to be happening at a certain rate. Is that correct?
Yes.
Okay, that is a different thing from device submit is not going to do that.
Because in device submit, we're going to have a scheduled task as the first argument, just like in session submit.
Okay.
Yeah. So
why is it different from session submit?
Yeah, they wanted a different name, yeah, because we had this discussion, Igor, and because they thought it was not appropriate to have. Yeah, and we also will need to specify the port to which it's connected, the device to which it's connected.
I understand, but the session submit has the feature that it is submitting. Let's see, does it go to the same kernel or to another kernel? There's local submit. Yeah, okay, so this is going to the same kernel. This is being executed in downtime of the current kernel, right? Whereas, for example, something like cloud submit is submitting something to be executed in the cloud.
Yeah.
Okay, you know what? Why don't we fork off another meeting to discuss this, to clean up anything that still needs to be done with the main things we were talking about, and then to deal with this device submit stuff. Okay. And if Igor wants it needed to be involved, please make sure he's in the meeting so we don't have a three-way mess.
Yeah. I think Igor should.
Okay. Yeah. Okay, great. And okay, let's get that. I sent you this notebook. Thank you for the comments from the live stream. Thanks, Suba. Anything else?
Nope.
Nope. Okay. See you all soon.
Bye-bye.
Okay. Bye-bye.
Bye.